was his ability to identify finches there. That was a complex system. It's a very complex system, just like any engineering complex system you can imagine. It was a complex system, but he was well trained. His eyes were critical. He could see things beyond the obvious. So from that, he was able to identify the differences between finches. And that observation helped him to develop the theory of evolution, which is still affecting Ecuador in many ways. I think his ability of reading complex information is exactly what I would like to see in our students, in our engineering students. When they look at that octopus movie, they should be able to see what is going on and then move on and think about, oh yes, I can do that. That has been our goal in the last 4 or 5 years at the University of Kentucky. But before going that, we would like to also talk about where or how the public sees these achievements. And in that sense, I came across with a book a few months ago. I don't know how many of you saw this book. This is a book by Kurt Vonnegut. He's an author. He's a well-known author in the United States. He wrote this book back in 1986. He talks about what happened. It was an interesting one because I think it's the only book I could see Kentucky, Turkey, Ecuador mentioned at once. Originally, I'm from Turkey, so I could see all of these mentioned in this book. But on top of it, he mentions a handheld computer, Mandrax. That handheld computer is capable of telling you whatever you can ask, whatever your question can be. That Mandrax is nothing more than a handheld iPhone like now. A handheld iPhone will allow you to get into the web, World Wide Web, to find your answer, your questions, and then move on. You can find your address, you can get the 16 digits of the speed of light or 64 digits of pi. It can find you a good recipe for ceviche. It can find your homework from your school. Maybe it is already in there. You forgot to write down what the homework was. You can go and read it from the website. And it was not talking about nanotechnology at all. At that time, it was science fiction. It was 86. It was like 30 years ago, 20 years ago. So it's amazing that he was able to talk about that. And it was going on, the entire thing was going on in Guayaquil and in Galapagos Islands. So there are so many indications that nanotechnology and Galapagos Islands and Guayaquil were connected. It was up there. That book by Kurt Vonnegut was talking about that. But I think this book should be reading assignment for all Ecuadorian students. Well, what do we do with this excitement then? Well, I think with the excitement of nanotechnology, ESPOL will be able to attract more students. And they will be able to study different disciplines, but they will be able to communicate with each other better. They will move together. They will understand they are different, but they will combine their efforts, their strengths together for a higher goal. But along the way, ESPOL administration should follow some of the guidelines. And one of that guideline was given by Charles West. He was the president of MIT. And when he mentioned this statement in 2004, I think he was talking about today. He mentioned we need to remember as the students are driven by passion, curiosity, engagement, and dreams. We have to dream. We have to give the dream to them. We have to engage them in action. We have to allow their curiosity to flourish. and we have to make sure that they carry the passion from day to day. Well, along with this, the collaboration with other universities is must. I think at the University of Kentucky, we have seen ourselves collaborating with different faculty members, with different universities, and with different disciplines. And I will give you a couple of things for the ESPOL to see. I just chose 2 slides. In Kentucky, we have a very strong presence of Ecuadorian students. And Ecuadorian students and communities of the American communities which have been traveling to Ecuador, unbelievably large. I don't know what happened. And then I went and found these statistics. But I found out that, I think these 2 slides are upside down. Let me go to the other one. Okay. Yeah, here. I found out that for US students studying overseas, Ecuador is very high. That's number 20 here. But there are several other much larger cities, larger countries. Still, number of students that sent from the United States to Ecuador is significantly high. When I go back and look at the number of students coming from Ecuador to the United States, well, I don't see them. There are not many students going from Ecuador to the United States. I don't know if Ecuadorian students are going to other countries. I think we have to look at that carefully. But I think if we can establish two-way street, the Ecuadorian students going to the United States, learning the tricks of the trade, and then coming here and staying with their families within their environment and helping the bigger problem, solution of the bigger problem, I think there will be quite big success. Well, with this idea, do I still have time? Okay. I would like to just mention a couple of things. I will go fast here. We have started a few education programs, and I think it will be interesting to start similar programs here. And at the University of Kentucky, I was involved with the honors program. I was involved in the certificate program, courses and concepts. These are, there are several other universities from MIT to Harvard to Berkeley to Stanford. They established similar programs over the years. But I think I'm very proud. At the University of Kentucky, I think we are one of the few, a handful of universities where nanotechnology is taught from day one. The honors program we started 4 or 5 years ago is basically for the the freshman students. They just come to the University of Kentucky. If they are interested, they start taking this class. Here we talk about the impact of emerging technologies on the society. It's a time travel. There we discuss the steam engine, we discuss the compass, which with its impacts to the trade. We discuss aqueducts, the water distribution and its impact to development of the cities. We discussed nanotechnology and speculate to a point. We understand it, and then we speculate where it will lead us. We talk about computers, history of civilization, and so on, all of them. But we excite the students about nanotechnology during that first year. Don't forget, these are the freshman students. They haven't taken their physics and calculus and chemistry courses yet. And what happened is, at the end of the semester, I am the professor for this class, I asked them to establish companies. And I'm showing you some of the slides from those virtual companies. At the end of the first year, they are quite excited. One of the groups, 4 of them, established a bio-nanotechnology company, for example, and they looked at the eyes. They thought about where they get the nano-knitting idea. This nano-knitting was important because they could come out with very strong materials. I'm not going to read all these things, but I just wanted to show the clips from their slides just to show how involved they were. They talk about how they are going to go about doing the research and how they are going to find money to do research.